In this part of the titration calculation, we're going to focus on pH before the equivalence point. So our sample is 25 mils of a 0.5 molar weak acid solution, and it's titrated with 0.8 molar sodium hydroxide. We want to know the pH after the addition of 10 milliliters. So we want to know at what point we are in the titration. So the first thing we really need to know is what the equivalence point is. I've already identified this as a calculation before the equivalence point, but we need to make sure that we know that because your questions won't be labeled. All right, so I use this equation, MAVA equals MBVB. So I plug in my acid concentration and volume, and I plug in my base concentration, and I'm going to solve for the volume of base that it takes to reach the equivalence point, and I get 15.626. All right, so now I'm going to set up a buffer type calculation because in the titration, I know that I'm reacting the weak acid with strong base and converting it to its conjugate, which is very similar to a buffer. The only difference is you start with some of the weak acid and you're starting with 0 of the conjugate. But when I get done, I will have some of both, which will be similar to a buffer. All right, so when you're doing a buffer type calculation, you need to find the moles. So I am going to multiply by the volume. So if you have 25 milliliters, that converted to liters is 0.0250. So I'm multiplying my molarity times the liters, and I get 0.0125 moles of the weak acid, and I still have 0 of the conjugate base. All right, so now I need to know my moles of strong base that are being added. So I have 80.8 molar sodium hydroxide, and I have 10 mils of sodium hydroxide, which is 0.0100 liters. So I'm going to multiply those together, and I find my moles of strong base is 0.008. So I'm going to react those. The strong base is going to react with the weak acid, so I'm going to subtract, and I am going to make the same amount of conjugate. So I get 0.0045 moles of HA and 0.008 moles of the conjugate. So I have both. That means I can use the Henderson-Hasselbalch equation. pH equals pKa plus the log of A minus over HA. And if I find my pKa, remember pKa is equal to negative log of the Ka, and I have that as 5.824. And I make sure that I plug in my base, my conjugate base, over my conjugate acid. And I get a pH of 6.074.